As I said in the previous video, the stronger the nucleus holds on to an electron, the more difficult it is going to be to remove that electron. And vice versa. The less it holds on to it, the less that nucleus is attracted to that electron, the easier it's going to be to pull it off. So what it all has to do with is, if you think about that, an electron is all the way out there, right? Because it's all the way out there. The reason why it's all the way out there is because there's no other space for the electron to be in an orbital that's closer. Because all of those orbitals, all the way to that outermost place that the electron is in, that we're talking about, is full with electrons in those orbitals. So what those electrons do that are in between the outermost electron and the nucleus, all those electrons that are in between, what they do is they get in the way of that attraction, okay? Not only is it physically far away, but those electrons that make that electron to be all the way out there get in the way of the attraction. And since they get in the way of the attraction of the nucleus, the outermost electron, all those electrons in between, what we say they do is that they protect that outermost electron from the attraction, or they shield that outermost electron from the attraction. So that those electrons that are in between the outermost and the nucleus shield. And the more electrons you have in between, the more shielding occurs. So large atoms with all those orbitals filled in with electrons have a lot of shielding electrons. And so if you think about the periodic table, like for example, in group 2, you have beryllium, magnesium, calcium, strontium, and barium. As you go down, they all end in S2, but each individual one of these atoms, their last electron is farther and farther and farther away. Beryllium's last electron is in the 2s2, magnesium in the 3s2, calcium 4s2, and so on and so forth. So when you compare beryllium's last electron, which is in the 2s2, right, it's got electrons in between that outermost and the nucleus, but barium has got 56 electrons, and it's got 55 electrons that are in between it and the nucleus. So barium has got way more electrons in between. It's further out, and those electrons that are in between shields barium's last electron. So if an atom is going to want to try and take away an electron, it's going to be harder for beryllium's electrons because it's so close to the nucleus. And barium is going to be all the way out there, so it's going to be very easy to remove its electrons. And what that means for atoms is that if an atom loses an electron, that means it's going to be easy to interact with other atoms and react, and we call that more reactive. So when we say, well, an atom loses electrons, why would that even happen? Well, by losing electrons, sometimes an atom has an advantage to doing that. Just like you and I, we all like stability in our lives. Well, atoms do too. So atoms want, and I put that in quotes because they don't want, all that kind of stuff, but it's sort of a human way of dealing with it and understanding it. Atoms want stability. They want to be stable. And by doing that, they obtain stability by being like a noble gas, by having their outermost energy level completely filled. And if they don't have electrons in their outermost energy level completely filled, then sometimes losing electrons is a real easy thing to do to make that happen. So for metals, what they generally do is they lose electrons, and that's why I put it bold, in order for them to have an outermost energy level that is filled. You lose the outermost, and then you go to the next level down, and now it's full. And that's the reason why metals have a low ionization energy. But non-metals are the opposite. They actually are close to having a filled energy level, so it's hard for them to lose electrons. So these elements that are over here on the left side of the periodic table, they lose electrons really easy because by doing it, they become stable. But these elements over here, they're almost with the filled energy level, so they don't lose electrons. They resist it, and so therefore it's going to be hard to remove electrons. And we'll talk more about that in detail. You will talk about that with your teacher about ionization energy more specifically.